Hi. As a part of looking at what's happening in Wi-Fi 8, I wanted to do some evolution analysis of some of the range extension efforts that IEEE has been putting into the IEEE standards. Of course, we know them popularly as all these 6, 7, 8 generations. My name is Srikanth, and I'm with NanoCell Networks. So the range extension efforts officially, as far as interoperable standards, started in 11AX or Wi-Fi 6, and they involved basically an XR PPDU or an ER PPDU as it was later called, which was primarily to design to address some of the challenges, especially for connecting over slightly longer distances with IoT devices out in the field. So the standards did some elaborate work by including a new PPDU type with power boosting on the preambles, a repetition of some of the 5-layer fields, signaling fields, restricting the MCS. So it was basically doing a lot of work sacrificing the data rates to get extended range. In fact, even now the standards have the option where the rates can go as low as up to 400 kilobits per second. Okay. I'll comment on how popular these have been maybe towards the end, but this is just to know that this is out there, and I know that some chipsets do support it. Okay, so the idea was the longer range, especially for some IoT kind of applications which don't demand very high data rates but might need good ranges. And the key technique was here called dual subcarrier modulation, where you basically sort of repeat in a certain what you call interesting way. There was no new MCS created, and what the standards did was specifically work out the physical layer PPDU details for this extended range by doing some twists and turns in the constellations that they used for some of the SIG fields. So it's, as you can see, it's quite deeply involved at the file level. So it needs to be supported by the chipsets because these deal with the 5-layer signaling fields. What happened to the story in Wi-Fi 7, or what we know as 11BE? Officially, it became the dual subcarrier modulation is now DCM. Of course, in 11AX also we had the name. Now we had an MCS 15. In fact, there's a closely associated MCS 14 as well. So these two, but I would specifically just stick for MCS 15, basically made it into a kind of a new MCS, which is basically can be signaled. So apart from the MCS 12, 13, which was added for higher rates, we also had this MCS 13, 14, or rather 14, 15, which basically added robustness. So it's a little bit of a challenge because higher the MCS does not imply higher the rates. So here basically we carried on with the repetition. So this was applicable even to the OFDMA case, which is where you get the lowest data rates possible and so on and so forth. MCS 14 was a slightly more what you call limited case, applicable to 6 gigahertz LPI kind of regime. So as I said, that's a slightly more what you call tuned case, whereas MCS 15 is applicable to multiple bands. And now we are in the era of Wi-Fi 8 or 11BN, and we are back to the story where we now have a new PPDU type called extended long range PPDU. I presume that this was based on some of the feedback received from the earlier times where they're trying to correct and add certain things to hopefully make it more popular. The focus is more on the 20 megahertz transmissions. Of course, all of them so far allow only one spatial streams. In this case, slightly more than other, in terms of modulation coding, other support with QPSK also included. And you can see the target with 20 megahertz is to get, numbers like this with this kind of a link budget advantage, which could result in better ranges and so on and so forth. In fact, the focus here, when we look at some of the discussions going on, is also specifically the limiting link of uplink. And especially on 5G and 6G, there's a focus towards supporting this or thinking that that might be the case where it might be really useful. Okay. So how do they do it? They basically do the same or a similar story as the dual subcarrier modulation, but only thing, because it's a 20 megahertz case, there is a repetition of the 52 tone. So with the data on the 52 tone getting repeated in some intelligent fashion on the other copies or other 52 tones. Okay. And as you can imagine that there is some dB of link budget advantage. There's a lot of thought going into how we'll coexist nicely with earlier generations. So now comes to this question, has this really been useful? This whole effort of extending the range, etc., by doing something at the PPDU level. And it's a question mark, because I have not seen interoperable solutions which have really taken off and people touting this advantage in the marketplace. People writing white papers about the standards and their features do talk about this. But when it comes to real products and real usage, we have not seen this really take off. So the question I might pose for others is why? I mean, is this really not useful the way it is? Is it only used for niche segments? And people who always say that Wi-Fi does not have this feature and that feature, I always comment that 802.11 has done a lot of work in putting together a lot of features, but somehow it might not have come to fruition in real life products in the way it has been envisaged. Anyway, this is just to trigger a discussion on something which has been happening on the sidelines, but has not attracted mainstream attention. So for more, you can visit our websites. We also offer course through Wi-Fi Now Academy. So I hope this has been useful to stimulate some discussion. Thank you.